Hi, everyone. My name is Jenny, and I'm a Senior Developer Relations Engineer at Edge Impulse. My CTO, Jan, is usually doing these keynotes every year because he's close friends with Johan, the CTO of the Things Industries. But I get to be the lucky presenter of this year's keynote for Edge Impulse. So today, I'd just like to talk to you about how Edge Impulse is helping rapidly develop AI models for production-grade IoT and edge devices and deploy them very quickly and easily. So the first thing I wanted to do is put into context of a use case of how we could use industrial IoT for designing machine learning models, optimizing data at the edge, and really decreasing the amount of loss of a factory pallet or assets in a factory. There's a lot of challenges currently in industrial IoT, as a lot of us know because we're in the IoT space. There's been a lot of advancements with data analytics at the edge, data analytics in the cloud, and more, in order to reduce the amount of loss in a factory, reduce and facilitate the time for maintenance, and more. Since the Internet of Things is a range of connected devices, we can view the pallets in a factory as an interconnected network of an almost infinite amount of data points if you're considering all of the factories that we have in the world. So how do we leverage all of this data on the edge? And that's why we're looking at a warehouse example today. We also expect asset tracking to be a huge market, and there's an estimate that the industry will grow to a $35 billion valuation by 2026. So this is something that we're definitely looking into, especially at Edge Impulse and with our customers. So this is a typical industrial gateway. There's Wi-Fi, LoRaWAN, every single type of sensor you can imagine, internal storage, and more. This is from Lexmark. This is the Opera Edge Gateway, Optra. But what does it actually do? It can ingest all of this data. It can process data at the edge. It can send data to the cloud. But what is the data actually doing? Where is it going? Currently, a lot of the interesting data that we see that is collected on these devices is either stuck on the device just because it's too inefficiently managed on the device because it's too large of data, or we can't send all of the data to the cloud due to the amount of data that we have, or it's all being sent up to the cloud and then nothing's really happening to it because it takes a lot of time to design custom algorithms in order to achieve a recognition that we want for our specific data in our use case. For example, identifying when a machine is about to fail. So we have all this data on the edge. It's being collected, as we see in IoT. All of our sensors, we have plenty of firmware that collects all this data. We can use this data in the cloud, but how do we actually identify patterns in this data? Well, a microcontroller, for example, will take in a temperature sensor, for example, and send that data up into the cloud. Currently, we see a lot of IoT devices just statically sending one temperature reading per hour or per minute up into the cloud for information and data analytics dashboards in a cloud platform, for example. But what about identifying various patterns? How can we see, hey, the temperature has varied in a way that we haven't seen before? That's currently very difficult with just static data collection from a temperature sensor on a microcontroller. We're not doing any pattern recognition. We're not doing any smart sensing there yet. We can also look at things like other patterns, like the vibration pattern heard will lead to a fault state in a week, or the machine oscillates differently than all of the other machines in the factory. These types of insights are currently very difficult to do, or we only receive these patterns identified in the cloud after the machine event has already occurred. So how can we see these events in real time, directly on the device on the edge? That's where we take rule-based engineering, which is currently what we do for the majority of IoT applications, where we have our use case where we want to identify Jan jumping up and down or doing motions with his hands with accelerometer data. We write our rule-based code that uses digital signal processing algorithms to identify what we want to detect on the device, in this case, a motion gesture. And then we just use trial and error to refine the algorithms over time in order to achieve our intended result. And then we write more code, and the process continues. So we want to go from rule-based engineering to data-driven engineering. Data-driven engineering is where we now take the sensors, utilize machine learning algorithms to help us find the rules, rather than us defining the rules for the sensors themselves. So we're using machine learning algorithms to identify the patterns that we want to find the intended result. So say we want to identify Jan's hands going like this. Instead of writing our own code to identify the digital signal processing needed in order to achieve that result, we're then just going to pass in the raw data into a machine learning algorithm, and that machine learning algorithm will learn to find that information in that data without us having to manually write it. So data-driven engineering is definitely the future. And it's going to be the biggest paradigm shift that we see since moving all of our data analytics from the cloud onto edge devices and IoT devices. And we see this as especially important in things like industrial IoT, health, and enterprise edge devices as well. Personalization of your algorithms is where the holy grail is for these edge devices. IoT and machine learning are just better together. If you're American, it's like peanut butter and jelly. If you're Dutch, it's like stroopwafel and coffee. But we really see ML-powered solutions will drive new value across all industries. It really starts with the edge, where we really want to bring the power of all the existing sensor data that we have and really utilize it in real time directly on the device. By deploying machine learning models onto these devices, we will no longer have to worry about things like bandwidth, latency, economics, reliability, and privacy constraints, because all of the data is being processed directly on the edge. And Microsoft has estimated that the edge is a $250 billion opportunity across enterprise segments. So, of course, this is something that we really want to look into in the next few years. And AI and ML are really hot topics, of course. So Edge Impulse is really on a mission to enable developers, hardware vendors, innovative enterprises, and more to take advantage of your software, of your sensor data on the edge, and use ML as it is right now today. We provide all of the major innovation, and we're always constantly creating new algorithms and machine learning tools available for you to use. So we talked a little about machine learning, how it can be valuable, the paradigm shift from rule-based engineering to machine learning-based engineering and data-driven engineering. What things can we actually do? So we talked a little bit about pattern identification. One of the things that I really wanted to highlight with industrial IoT, for example, is how we can deploy machine learning-based algorithms to edge devices in factory environments. So one of the things that we're really looking at is predictive maintenance, where these devices that you see in the image, there's multi-million-dollar robots. We don't want them to break down, and we don't want to have humans go into the factory, reduce the time in order to fix the robot, et cetera, et cetera. How can we utilize various devices on top of the robots in order to detect when things are just about to fail or are in the process of failing? This will allow us to drastically reduce the time needed in order to restore our factory to 100% efficiency. What else can we do? We can do things like production quality and optimization with computer vision. We can do visual inspection or skew detection, so we can reduce the amount of manual interference from human intervention needed in the factory. We can do machine monitoring with motion, current, and sound. We can also monitor equipment health and remote monitoring and optimization. So AI and machine learning really creates an experience where the machine can talk to other machines rather than having a human intervene. And these decisions can be made autonomously as long as we have the machine learning model already on the edge device. The world of IoT is expanding, and with the power of AI and machine learning, the sensor world is even unlocked further. So this is just a little bit more about the asset tracking, which we've already discussed. But the implementation here is something that can be very easily done with tools like Edge Impulse and other machine learning tools for edge devices. And this really drastically allows us to reduce the amount of battery, latency, economics, reliability, and privacy, or BLERP. I'll be using that acronym a lot in this talk. But we can gather things like vibration and accelerometer data. We can label and train a model to identify whether a pallet is on a forklift, inside or outside, using various sensor data. As long as you know what you want to achieve, these types of patterns can be identified with machine learning algorithms. By 2025, more than 95% of new industrial IoT deployments will include analytics and AI edge inference capabilities, up from less than 25% in 2021. And we see this again with our customers at Edge Impulse and more. So what is Edge Impulse? I'm talking about this a lot. Edge Impulse is the first fully integrated machine learning platform. It's also the leading platform for building, refining, and deploying machine learning models and algorithms to edge devices. And it also plays a key role in the development of AI models and applications for various things like industrial health monitoring, industrial factory monitoring, health, and more. We cover the full development cycle, from collecting your data, designing and training your machine learning algorithms, and deployment of the firmware to your edge device. And then, with all the help of you guys in this room, we can do things like over-the-air deployments via various wireless techniques or LoRaWAN. We also have a royalty-free business model, and it's free to sign up for Edge Impulse at studio.edgeimpulse.com. We're powering the largest edge AI ecosystem with over 90,000 developers, 230,000 projects, and 5,000 enterprises. We're also trusted by leading enterprises like Oura Ring, Polycom, Sony, SAIC, Lexmark, and more. Like I said before, we transform the entire process from data collection all the way to deployment. Data collection is probably one of the hardest things that we see in the IoT world, as most of you know. So Edge Impulse allows you to very quickly, rapidly generate a data set specifically for machine learning purposes. You have your training and your testing data set. All can be done quickly with the tools provided for free by the Edge Impulse tools or via our enterprise offering. You can also design your digital signal processing algorithms, your machine learning algorithms, and even test your model directly on your Edge Impulse account before you deploy it to the edge, rapidly reducing the costs needed associated with developing your machine learning model for production-grade devices. We also provide firmware for any class of edge device, anything from a low-end microcontroller all the way up to a CPU, GPU. So there's no constraints here. You can develop your machine learning model for one class of device, and then in the future, you can decide, hey, I'm not sure if I want to use that device anymore. I want to try to use a GPU, for example. You can use that exact same model using the same exact tools you used to create your first model in Edge Impulse. So the options are unlimited. Edge Impulse is also pioneering the Edge AI revolution. We constantly come out with brand new algorithms, new integrations, and more. These are just some of the things that we've released recently. Data campaign dashboards, auto-label anything with the meta AI algorithms, and we also have integrated recently with NVIDIA Tau, which allows you to very directly access the latest and greatest in machine learning for your edge devices. The future is at the edge, and one of the two cool things that I wanted to point out today is we recently released a brand new anomaly detection algorithm called GMM, which is very similar to k-means, if anyone is in the room that understands that. But basically, we can allow you to upload a purely nominal sensor data set, and without having to do any device finagling on the edge, you can detect when a machine is going to break, or if a machine is performing nominally, before you even collect that non-nominal data. So these algorithms are really cool, and they're all available for you for free within the Edge Impulse tool. So what have we learned? The cloud and edge compute limitations are vast, from bandwidth, latency, economics, reliability, and privacy. Blurb is one of the big things that we talk about all the time at Edge Impulse, and it's what we're always trying to help our customers to reduce. Transforming edge devices to be more responsive to the real world will be using Edge AI in the future. Machine learning makes devices smarter, and Edge Impulse helps with the rapid development and deployment to the edge. Thank you so much for listening, and sign up for a free account at studio.edgeimpulse.com. Our docs are available at that link, and if you have any questions, please reach out. And if you'd like to learn about even more use cases, not just industrial IoT, I actually wrote a book that was published by O'Reilly earlier this year called AI at the Edge. Thank you.